So we are going to get started with solving 1 and 2-step equation. So this is like a pure algebra. So let's take a look. So if you take a look at number 1, you will notice that 12 is equal to 3x. So we always isolate for x, a variable. Whatever it's in front of x, we divide that by completely. So in this case, 3 is in front of x, so we cancel, we divide it. So 4 is equal to x. On the other hand, if I were to have a fraction, I can move negative 11 to the other side by multiplying because it's division here. So opposite of division is multiplying, so x is equal to 3 times negative 11. So x is equal to negative 33. Now what about number 7? In this case, it's x minus 4. So I want to move negative 4 to the other side. So negative 4 becomes positive 4, or subtraction, right? It's an expression, so x is equal to negative 5 plus 4. Therefore, x is equal to negative 1. Now, what if you were to be given a question like number 11? Same thing, I'm going to move 3 to the other side. So opposite of dividing is multiplying. So y minus 4 is equal to 7 times 3, which is 21. And I'm going to move negative 4 to the other side. So it will become positive 4. So 21 plus 4 gives me y is equal to 25. Now, if you take a look at number 16, on the other hand, we have x in the denominator. So I want x to be alone, but right now it's with minus 1. So we have two terms here. So I want x to be alone as a 1 term, so I'm going to move negative 1 to the other side. So 4 over x is equal to negative 2 plus 1. So I simplify, which is negative 1. Again, so what I'm going to do, I want x to be alone. So I'm going to move x to the other side. So opposite of dividing x is multiplying. So it's like 4 is equal to negative 1 times x, which is negative x. Now, in front of x, we have negative 1. So we're going to divide whatever it's in front of x, which is negative 1. So it cancels out. So x is equal to negative 4. Now, what about number 18? So as you can see, I want t term to be alone. So I'm going to move negative 6 to the other side. So on my left side, I have 3 over t, negative 1 plus 6. So 3t is equal to 5. And now I'm going to move t to the other side. So it's 3 is equal to 5 times t. So if that's the case, whatever it's in front of t, which is 5, divide it, cancel, cancel. So t is equal to 3 over 5. So I decided to put it in a fraction because I don't want to have decimal. Okay. So you could do a check method, which is left side equals right side, as like what we did last time. But let's work on a word problem. Okay. So let's take a look at number 22. Lisa is cooking muffins. The recipe calls for 7 cups of sugar, and she has already put in 2 cups. How many more cups does she need to put it in? Well, the question is saying how many more cups. So we could say let x be the number of cups that she needs to put in. So therefore, she has already put in 2 cups. So it's going to be 2 plus x is equal to 7. So it's a very simple math, but you need to be comfortable how to get an equation. So I'm going to move 2 to the other side, so x is equal to 5. So therefore, she will need 5 more cups to make it a 7 cups of sugar. Okay. What about number 27? So how many boxes of envelopes can you buy with $12 if one box costs $3? So again, the question is asking how many boxes. So we're going to say let x be the number of boxes. So that means one box is $3. So then 2 boxes is going to be $6. So it's a multiple. So we will say 3x is equal to 12 because it's $3 per box. Therefore, we divide both sides by 3. So it cancels out. X is equal to 4. So therefore, she will need, she can buy 4 boxes in total. Okay, good. So you will do always tackle the word problem with the let statement first, and then set up an equation. Now, what about if it involves a multi-step? So take a look at number 1 here. So it looks like we have a like term, r, and -2 and +18. So let's collect the like term so that the variable is on the left side and a number is on the right side. So on the left side, I already have r. Negative r will now become positive r. And on the right side, I have 18. And -2 will finally become +2. Now keep in mind, every time you move things across the equal sign, you switch the sign. It becomes opposite. So r and r becomes 2r equals 20. Whatever it's in front of a variable, we divide completely by that number, which is 2. So r is equal to 10. Now, what about if you were to have like a bracket here? So if you have a bracket, we need to open up the bracket by doing a distributive property. So in this case, 3 times x, 3 times 6, and 2 will also be doing distributive property. So it will be 3x plus 18 equals 2x minus 2. So we're multiplying. And now I'm going to collect the like terms. So I'm going to put x's on the left side and numbers on the right side. So positive 2x becomes -2x. And positive 18 will become -18. So x is equal to -20. Now, what if you were to have like a fraction here? So same thing here. We have to distribute, and distribute, whatever it's in front of a bracket. So it will be 2 over 3x plus, so you do the numerator. So 2 times 3 is 6 over 3 equals 4. But you will notice that 6 divided by 3 is actually 2. So I can simplify it. And then I can move positive 2 to the other side by collecting the like terms. So 4 minus 2 will be 2. And then we are going to divide whatever it's in front of x. So we're going to divide this by 2 over 3. And we're going to divide this by 2 over 3. So that it will cancel and cancel. Now, when you are stuck with dividing a fraction, what you can do is do the opposite of dividing, right? So you flip the second fraction, so it's going to be 2 times 3 over 2. So that's the rule with fraction. Change the division to multiplying and you flip only the second fraction, or so the second term. So therefore, x is equal to 2 times 3 is 6 over 2, which is 3 when I simplify. Okay, now what about if you were to have, let's say, a fraction equal fraction? So take a look at number 14. So when you have one fraction equal another one fraction, you can do something called a cross multiplication. So we cross multiplying. So it's going to be 4 times 3x minus 2 equal sign 2 times 6. Then I will be doing distributive property here. 12x minus 8 is equal to 12. So just by cross multiplying, we get rid of a fraction right away. And this can only be possible when you have one fraction equals another fraction. Then I'm going to move negative 8 to the other side, so it's 12x equals 12 plus 8, which is 20. And you will notice that we are going to divide everything by 12. So when I simplify, it will become 5 over 3. The reason why is because I can divide both sides by 4 and 4. So I can simplify it to look like that. Okay, so you want to simplify your answer as much as possible. Okay, good. Now, what about if you have sort of like an expression? So for number 18, we have a fraction plus a fraction equals a number. So if that's the case, you cannot do crisscross. Okay, cross multiplication doesn't work. So you have to find the lowest common denominator. In this case, my lowest common denominator is going to be 3 times 7, which is 21. So I'm going to multiply everything by 21 on the first term, the second term, and the last term. So when you do this, I can be written this as, it's like saying 21 times x plus 1 plus 21, don't forget the bracket, x minus 2, and 21 times 1. But you will notice that I can simplify this, right? So 21 divided by 3 is 7, x plus 1. So the purpose is, after you multiply the lowest common denominator, you will notice that you can get rid of the fraction by dividing, because they are the common multiple. And then 21 divided by 7 is 3 times x minus 2 equals 21. So this is a good method because we get rid of the fraction. And we're back to the basic, where we distribute. And I'm going to collect the like term. 10x plus 1 equals 21. And I'm going to move positive 1 to the other side. So 10x is equal to 20. And you're going to divide both sides by 10. So x is equal to 2. Okay. So just keep that in mind when you have a fraction for more than one term on each side. So let's try doing some word problems. So number 19. Aliyah had $24 to spend on 7 pencils. After buying them, she had $10. How much did each pencil cost? So your let statement, let X be how much? So the cost of each pencil. That's what it's asking. So we know that the total is $24 and each pencil, okay, so she spent on 7 pencils, so 7 times X, right? Each is 7, and plus 10, because she had a $10 left over. So after you set up an equation, I'm going to move positive 10 to the other side. So it's 14 equals 7x. And divide by 7. So 14 divided by 7, which is 2. So therefore, each pencil is $2. Okay. Now, what about number 22? So Sumali won 40 super bouncy balls playing horseshoes at her school's game night. Later, she gave 2 to each of her friends. She only has 8 remaining. How many friends does she have? So we could say, let X be the number of friends that she has. So she started with 40, right? And she gave 2 to each of her friends. To each means, so minus 2x. So if she has 2 friends, then it's going to be 4 that she gave out. And is equal to 8. 8 is remaining. So therefore, I'm going to move 40 to the other side. So it's on the left side, I have negative 2x equals 8 minus 40, which is negative 32. Now, what's in front of x? Negative 2. So let's divide both sides by negative 2. It cancels out. X is equal to 16. So what does that mean? Therefore, she has 16 friends. Okay, very good. And that's it. Okay, I do want to go over number 24. Okay, so just for the equation. So let's see. So how old am I if 400 reduced by 2 times my age is 244? So you could say, let X be my age, right? It's asking how old am I? So if that's the case, so it's 400 reduced by, reduced means minus, 2 times my age, which is 2x, is equal to 244. Okay, and then there you have it. So all you need to do is collect the like terms and isolate for x. So I'm going to move 400 to the left side. So negative 2x equals 244 minus 400, which will net negative 156. And then don't forget, divide both sides by whatever it's in front of x. So x is equal to 78. So therefore, I am 78 years old.